Imagine you're running a commercial fish farm. You know, you're constantly looking for ways to maximize your yield. You're relying on super expensive feed, selective breeding, carefully calibrated water chemistry. And
Wait, the margins are incredibly tight in that industry.
exactly, they're razor thin.
Yeah.
But imagine someone walks in and just offers you a 33% increase in the body mass of your fish.
Wow. Just out of nowhere.
Yeah. No genetic modification, no experimental growth hormones, nothing like that. Just the simple application of a static electrical field to the eggs for a few weeks.
It sounds completely made up.
Right. It sounds like science fiction or like one of those late-night infomercials. But this was a documented, patented reality in the 1980s. And the fact that you aren't using it today, that tells us a whole lot about how our world is actually run.
It really does.
So welcome to Dive In. Today we are taking a deep dive into a concept that honestly completely upends our fundamental understanding of biology, agriculture, and, well, the invisible forces that govern living things.
Yeah, we are absolutely looking at a paradigm shift here because, we tend to view plants and animals through this strictly mechanical, chemical lens. Like, we treat a garden like it's just an organic factory.
Right, like an assembly line.
Exactly. You input water, sunlight, nitrogen, and you output a tomato. But doing that means we are entirely ignoring the electromagnetic architecture that actually tells that tomato how to grow in the first place.
And to understand that architecture, we're going straight to a meticulously detailed manual today. The exact title of our guide for this deep dive is Electroculture, Radionics and Biophotonics, a synergistic approach to enhancing plant growth and health.
It's a highly technical title.
Oh, it really is. It's written by Thomas Imlauer. And to give you a sense of who we're dealing with here, because this is important, Thomas is not some mystic. He's a literal electrical engineer.
Yeah, that's a huge point to make right up front.
Right. He spent 20 years working as a systems engineer in London. And he developed this profound, lifelong fascination with Nikola Tesla. Now he's retired, living in Romania, where he founded a company called Vortices Dynamics. And he actually documents all his ongoing experiments on his YouTube channel, which is called The Old Scientist.
And that engineering background is just crucial here because, when someone brings up concepts like electroculture or invisible energy fields, the conversation often just drifts straight into pseudoscience.
Right, it gets very crystal healing very fast.
Exactly. But Imlauer, he anchors all of it in quantifiable data. He approaches plant growth with the rigorous mindset of a systems engineer. He wants to, measure the voltage, map the magnetic flux, document the exact growth multipliers.
So our mission for this deep dive is to explore the mechanics of how electricity, magnetism, and scalar fields can radically supercharge plant growth. But more importantly, we're going to break down Imlauer's DIY experiments so you can actually replicate his systems right in your own backyard.
Which is the best part, honestly.
Totally. But I think the natural starting point is, figuring out how an industrial electrical engineer ends up writing a treatise on agriculture in the first place.
Well, I began back in 2012 in England with this completely serendipitous anomaly, just a happy accident. Imlauer was conducting these bench experiments involving orgone energy devices.
Let's clarify that term for a second, because orgone can sound a bit out there.
Yeah, fair enough. So orgone was this concept proposed in the 1930s by a psychoanalyst named Wilhelm Reich. He basically theorized this universal ambient life force energy. And, while mainstream science largely dismissed Reich, Imlauer was interested in the physical, measurable reality of ambient electromagnetic fields.
Right, he was looking at the actual physics of it.
Exactly. He was using what he called space energy activation devices to capture that ambient background charge.
And he just had some ordinary houseplant sitting around his workspace, right? Just for decoration.
Just hanging out on the bench, yeah. And over time, he noticed this massive discrepancy in their growth rates. One specific plant was just exploding in size compared to a control plant sitting a few feet away.
And the only difference was that the thriving plant happened to be placed right next to a copper ground wire that was connected to his energy activation device.
Exactly. The ambient electromagnetic environment was acting as this massive biological catalyst.
So that observation just fundamentally shifted his entire focus. It proved that the local electrical potential was interacting directly with the cellular development of the plant.
It really did. But the fascinating part to me is that while Imlauer applied modern engineering to this, the core observation itself is actually ancient. We have this completely forgotten lineage of scientists noticing this exact same phenomenon.
Now it goes way back.
You can trace it back to the 1740s in France. There was this researcher named Ebner. He suspended metal wires over plants, electrified them, and conclusively demonstrated that static electricity actually accelerates the capillary action and the flow of sap inside the plant.
That is wild, the 1740s.
Right. And then by the 1890s, you have Justin Christoflo building these massive atmospheric antennas on commercial farms, just trying to draw ambient atmospheric charge straight down into the soil, and it resulted in vastly improved crop yields.
But okay, those historical examples highlight this undeniable interaction between electricity and biology, but it leads to a rather cynical realization.
Yeah, I think I know where you're going with this.
What if any rational person listening right now is asking the exact same obvious question? If a simple copper wire or a basic atmospheric antenna demonstrably supercharges crop yields,
Why aren't we using it everywhere?
right, why aren't modern commercial farms using this? Why are we spending literally billions globally on synthetic chemical fertilizers?
To understand the suppression of this technology, we really have to look at the economic structure of scientific research. And the most glaring example of this is the buried trout patent you alluded to earlier.
Yes, the Swiss trout. Tell them about the trout.
Okay, so in the 1980s, there was this massive Swiss agrochemical giant named Synergistic. They employed two researchers, Guido Ebner and Heinz Schurch, at their facility in Solothurn, Switzerland. And they basically wanted to test what would happen if you applied these electrostatic principles to higher organisms, not just plants.
Right, so they took ordinary, commercially available rainbow trout eggs, they artificially inseminated them, and then just placed them between two plates, generating a high-voltage electrostatic field for 4 weeks.
And the parameters were incredibly simple. It was high voltage, but essentially zero current. So it wasn't electrocuting the eggs, obviously. It was merely immersing them in this static field.
And the results were just mind-blowing.
Beyond mind-blowing. The trout that hatched from those field-exposed eggs experienced a 33% increase in their body mass compared to the control group.
33%.
Right. And furthermore, the fish actually exhibited characteristics of their historical wild ancestors. Like they were far more robust, they had way stronger immune systems, and they required significantly less food to reach maturity.
Which is insane. I mean, a 33% yield increase for a commercial fishery is the holy grail. It is a literal biological cheat code. It's essentially like discovering a free cheat code for a video game, but the developers lock it away because it threatens their highly profitable microtransactions.
That is a perfect analogy because Synergistic was, at its core, an agrochemical company. Their entire business model relied on selling recurring chemical inputs, pesticides, synthetic fertilizers, chemical treatments.
Right.
So developing a technology that only requires a one-time purchase of a battery and some metal plates to produce massive biological gains, that is a direct existential threat to a chemical company's bottom line.
So they just buried it.
Yep. Synergistic filed a patent with the European Patent Office just to secure the intellectual property, and then they deliberately shelved the research. They locked it in a vault. Because the commercial incentives of the agricultural industry fundamentally do not align with non-chemical open source breakthroughs.
Man, it is deeply frustrating to hear that. But recognizing the corporate intrigue doesn't really explain the underlying science. Like, we know that an electrostatic field makes a trout grow larger or a seed germinate faster. But we need to transition from the history to the physics here.
Right, the how.
Yeah, how does a static field actually communicate with a biological organism?
And this is where Imlauer's book becomes incredibly profound, honestly, specifically through his integration of biophotonics and radionics. His central thesis argues that plant growth is fundamentally an electromagnetic process that just happens to utilize chemistry as its building material.
The chemistry is the brick and mortar.
Exactly. And the electromagnetism is the architect handing out the blueprints.
So let's break down the biophotonics part first, because I think that explains the internal communication of the plant, right?
Yeah, definitely. So research over the last few decades, heavily pioneered by physicists like Fritz Albert Popp, has proven that living cells emit ultra-weak photons. Particles of light. We're talking about emissions in the 200 to 800 nanometer range.
Meaning living cells are essentially acting like tiny biological lasers.
Basically, yeah. They generate coherent light to communicate, to regulate cellular functions, and to coordinate growth cascades. So the plant is essentially this highly sensitive fiber optic network. And when you introduce an optimized electrostatic field, you're providing a frictionless environment for that biophotonic network to operate.
You're clearing the static off the line.
Exactly.
You're giving them a clear signal.
But the title of the book also highlights radionics. And, this is a term that carries a lot of baggage. It often gets misunderstood.
Mm.
In this specific context, what actually is radionics? So, radionics is the theory that every physical substance, whether it's a pathogen, a nutrient, a growth hormone, possesses a unique, fundamental electromagnetic frequency, a resonant signature.
Yep.
And if you can identify and transmit that specific frequency, you can actually induce the biological effect of that substance without the physical chemical ever being present.
See, that sounds completely impossible. Until, I guess, you introduce the concept of scalar waves, which is the exact carrier mechanism Imlauer relies on here.
Right.
Because we're all familiar with conventional transverse electromagnetic waves, like the radio waves connecting your smartphone to a cell tower. They oscillate up and down as they travel forward, like waves on an ocean. And they lose energy pretty quickly as they interact with the environment.
But scalar waves are different. They are longitudinal. They pulse in the direction of travel, compressing and expanding, much more like how sound waves move through the air. Professor Konstantin Mail, whose theories Imlauer applies very deeply in the book, suggests that these longitudinal scalar waves can pass through solid matter without losing energy.
Which is a huge deal.
Massive. Because more importantly, they act as this hyper-efficient conduit. They can carry the radionic signature, that material information, of a substance we just talked about directly into the biophotonic network of a plant.
Does this mean we need to stop looking at plants as passive chemical factories and literally start treating them like highly sensitive antennas tuning into their environment?
That is exactly what it means. And if that is the case, the logical next step is figuring out how to build a better tuning fork.
Right, and thankfully, Imlauer provides highly specific DIY instructions for doing exactly that, starting with passive geometry.
Because in electroculture, the physical geometry of an object dictates how it shapes and concentrates the ambient electromagnetic field. Imlauer focuses heavily on pyramids for this.
Yeah, he uses two distinct shapes, right?
Right. He utilizes the Cheops pyramid, which features a 52-degree slant that mathematically mirrors the Great Pyramid of Giza, and then the Russian, or PHI pyramid, which has a much steeper 71-degree slant.
And the PHI pyramid is entirely derived from the golden mean ratio, 1.618, which is this mathematical signature found all throughout the natural world, from the spiral of a nautilus shell to the arrangement of leaves on a stem.
Yeah, it's everywhere.
And the geometry you select actively changes the focal point of the energy within the structure. Like, you can actually measure a temperature differential inside these pyramids compared to the ambient room temperature.
It's incredible, and constructing them is surprisingly accessible for anyone listening. Imlauer's protocols require basic A4 paper, some cardboard for structural rigidity, and double-sided tape. That's it to start. The geometry does the initial work, but the materials are what turn a cardboard model into a functional electroculture device.
And this requires met glass and conductive metal tape.
Yeah, let's talk about met glass because it's fascinating. It's an amorphous metal foil. Unlike normal metals, which have this rigid crystalline lattice at the microscopic level, an amorphous metal has a totally disorganized, glass-like atomic structure.
And the reason that matters for electroculture is magnetic efficiency. In a normal metal, when a magnetic field passes through it, the magnetic domains have to sort of snap across those crystalline boundaries, which causes friction and energy loss. That's a process known as magnetic hysteresis.
Right.
But because met glass lacks those internal boundaries entirely, it acts as an incredibly efficient magnetic flux concentrator. It just gathers the ambient magnetic field of the Earth and funnels it directly downward into the plant.
But if you attempt this build at home, there is a critical safety warning regarding the met glass.
Yes.
Imlauer stresses that you must never sharply crease or fold the foil. Because of its amorphous structure, it is physically very brittle. If you fold it, you literally fracture the internal atomic lattice.
And that fracture creates a hard boundary, which basically breaks the magnetic continuity and completely ruins the flux concentration.
Exactly. You have to handle it in smooth, gentle curves, no hard angles.
Right. So once you have affixed the met glass to the inner panels of the pyramid, you bind the edges together using conductive copper or aluminum tape. This just ensures the entire geometric structure shares a single, continuous electrical potential. It operates as a unified, passive antenna.
And while a single pyramid definitely yields measurable growth advantages, Imlauer found that clustering 3 to 5 of them together and meticulously aligning their faces to true magnetic north creates this compounding resonance that drastically accelerates seed germination.
Now, passive systems are great for harnessing background energy. However, in his data, Imlauer documents growth advantages reaching a 15.6-fold multiplier.
Yeah, that's huge.
You simply cannot achieve a 1,500% growth increase with a cardboard cone and some foil. To hit those numbers, you really have to transition to active electronics. You need a powered system.
And the engine of his active system is a highly specialized piece of hardware. It's called the bifilar spiral pancake coil.
Which sounds like something straight out of a science fiction propulsion drive.
Yeah. It really does sound sci-fi, but it actually traces back to a real patent filed by Nikola Tesla in 1894. Patent US 512,340.
Okay, a real Tesla design.
Yeah. Most electromagnetic coils are cylindrical, like the copper windings you'd see inside an electric motor. But a pancake coil is entirely flat. Imlauer builds these by taking an MDF board, mounting it on a slow-spinning rig, and laying down double-sided carpet tape. And as the board spins, he presses the copper magnet wire flat against the tape, just spiraling outward from the center.
And the term bifilar means he's winding two separate strands of copper wire simultaneously, right side by side.
Yes.
But the true genius of Imlauer's physical construction is how he manages the electrical stress on this thing, because he winds a standard nylon thread directly between the two copper wires, acting as a physical spacer.
And that nylon thread is absolutely critical. In an active electroculture system, you're pushing really high voltages through these wires.
Yeah.
If two copper wires carrying vastly different electrical potentials are sitting flush against each other, the voltage will just arc right across the microscopic gap.
Shorting out the entire coil?
Instantly. The nylon acts as a dielectric insulator. It physically separates the windings just enough to drastically lower the capacitance and exponentially increase the breakdown voltage, which allows the coil to safely handle the high power input without literally destroying itself.
And the flat geometry of the pancake coil forces the magnetic field to project outward in a highly focused longitudinal scalar wave rather than a messy looping magnetic field.
Right.
So with the pyramids and the coils constructed, Imlauer applies them through this rigorous chronological three-stage protocol. Let's break that down for the listener.
Okay, so stage 1 is seed treatment. And this is where we actually return to the Ebner Effect that produced the giant Swiss trout. Before the seeds ever touch soil, they are exposed to a high-voltage electrostatic field for 80 hours.
Wait, I need to interject with a severe safety warning here.
Yeah, absolutely.
Stage 1 utilizes 10,000 volts of direct current. This is lethal voltage if mishandled. You cannot attempt this stage unless you are deeply trained in high-voltage safety protocols, you know how to properly discharge capacitors, and you use heavily insulated tools.
Please do not try this casually.
Exactly. Okay, but why so much power?
The high voltage is essential because it creates a massive potential gradient. And what is really brilliant about Imlauer's approach here is his modification of the original Ebner design. Ebner placed the positively charged high-voltage plate beneath the biological sample, but Imlauer reverses this. He places the 10,000-volt plate high above the seeds and grounds the plate below them.
Right. He does this to mimic the natural environment, because in nature, the Earth is negatively charged and the ionosphere above us is positively charged.
Right.
By placing the massive positive voltage above the seeds, he's artificially replicating the electrical tension of an impending violent thunderstorm. The biophotonic network within the seeds detects this massive atmospheric potential. Biology basically assumes a massive influx of rainwater is imminent, which triggers an aggressive, accelerated germination cascade.
Yeah.
The seeds are essentially tricked into waking up early.
It's biological hacking. So following that 80-hour atmospheric simulation, the seeds move to stage 2, which is soil treatment. Now, you do not treat the seeds here, you treat the environment they are about to enter. Imlauer passes a low-intensity direct current straight through the root zone of the damp soil.
And the goal here is sanitization, right?
Exactly. Through a process called electroporation, that specific low-intensity current disrupts the cellular membranes of simple single-celled pathogens and harmful molds. It neutralizes them without requiring any toxic chemical fungicides.
But the roots themselves are safe.
Yes. Complex plant roots are entirely unharmed by this specific voltage gradient. The soil is just electrically scrubbed.
Brilliant. So with primed seeds and sanitized soil, the system enters stage 3, plant treatment. This involves continuous low-power exposure to the scalar waves generated by those bifilar pancake coils throughout the entire growing cycle.
And this brings us to what I consider the absolute apex of this book. It's a documented trial Imlauer calls the Phase 2 experiment. It tests the absolute limits of both radionics and biophotonics.
Oh man, this experiment forces us to reconsider the entire definition of a chemical reaction.
It really does. So Imlauer sets up a scalar transmitting coil on a bench. Several feet away, he sets up 2 receiving coils. On the first receiving coil, he places a petri dish containing his pre-treated seeds. On the second receiving coil, he places a sealed pharmacy flask.
And inside that flask is a highly diluted plant growth hormone dissolved in water. Now, the physical setup here is crucial for you to understand. The growth hormone is completely isolated inside a glass jar. The seeds are isolated in a dish on the other side of the bench. They never physically touch. Not a single drop of liquid is transferred.
Not one. So Imlauer powers the transmitting coil. The scalar waves move longitudinally, passing right through the pharmacy flask. And as they do, they pick up the unique radionic frequency, that electromagnetic signature we talked about, of the growth hormone.
Wow.
The wave acts as a carrier, transmitting that specific chemical frequency directly into the biological structure of the seeds sitting in the petri dish.
And the biophotonic network inside the seeds receives that frequency and resonates with it. The seeds chemically react as if they have been physically soaked in the growth hormone, despite only ever receiving an electromagnetic radio broadcast of its molecular blueprint.
It is literal magic.
It's the biological equivalent of downloading a software update over a Wi-Fi network.
The implications of that mechanism are staggering. I mean, it suggests that a vast amount of biological interaction isn't strictly reliant on physical chemical contact at all, but on frequency resonance. If a plant's cellular network can receive, decode, and execute a growth command from a remote scalar field, it just completely validates the premise that biology is fundamentally an electromagnetic phenomenon.
And that leads to a deeply provocative thought that extends far beyond agricultural yields. I mean, we started this deep dive thinking about maximizing the tomatoes in a backyard garden. But if a simple copper wire, a passive geometric structure, and a targeted scalar frequency can dramatically rewrite a plant's physical growth rate.
Right.
What is our modern environment doing to us?
Right. It's a bit terrifying to think about.
We spend our entire lives submerged in this invisible ocean of Wi-Fi routers, cellular towers, alternating current electrical grids. What radionic signatures are those fields carrying? And how is our own cellular biology responding to that constant, unseen broadcast every single day?
It is a profound question. We are utilizing vast amounts of electromagnetic technology for communication and convenience, with very little understanding of how those transverse waves are interacting with the biophotonic coherence of human tissue. Because Imlauer's work proved that biological systems are exquisitely sensitive receivers.
They really are. Well, if you want to dive into the schematics, print out the exact pyramid angles, or see the meticulous voltage data for yourself, you need to engage with the source material directly. The book is Electroculture, Radionics and Biophotonics, a synergistic approach to enhancing plant growth and health by Thomas Imlauer.
It bridges a century of suppressed historical observation with rigorous modern engineering. It just provides a highly practical toolkit for anyone willing to experiment.
And the book is available on Amazon Global, so the next time you put a seed in the ground, remember that the recipe requires more than just soil and water. The invisible architecture is already there. You just have to learn how to tune the antenna. Thank you for joining us on this deep dive. We'll see you next time.